Hello friends, we are studying successive differentiation, and in that we are obtaining nth derivative of some standard functions. Earlier we have obtained the nth derivative of these some standard functions, that is nth derivative of ax plus b to the power m is m factorial divided by m minus 1 factorial, etc. So these formulae we have obtained up till now, and we have to remember these formulae for getting nth derivative. Now next we shall consider the nth derivative of e to the power ax sine of bx plus c with respect to x. Now how to obtain the nth derivative of this product, that we shall see. First is the exponential function and the second is the trigonometric function. Now let y is equal to, the given function is e to the power ax sine bx plus c. We differentiate this first one time with respect to x. Differentiating both sides with respect to x. Now what we shall get, the left side is derivative of first derivative we are getting only, and derivative of y, that is y1. So we get y1 is equal to, on the right side this is the product of two functions. So we must have to use the product rule. And using the product rule, see, derivative of the first, we write the second as it is. What is the derivative of e to the power ax? That is e to the power ax into derivative of ax, that is a. So it is a e to the power ax is the derivative of this. Second function sine bx plus c, I shall write as it is. Now next we keep the first function as it is and we have to write the derivative of second function, and that is, the first function is e to the power ax and derivative of the second, derivative of sine of bx plus c, and that will be cos of bx plus c into derivative of bx plus c, which is b. So that will be b cos bx plus c. So this is the first derivative of this function that we have obtained. But further what we shall do is, we can write e to the power ax common. That is y1 is equal to e to the power ax into bracket a sine of bx plus c plus, and now the second is b cos of bx plus c. This is taken common, and now we want to express this bracket in terms of trigonometric formula of sine, and for that purpose we use this values of a and b as particular values, and we take the values of a and b as, take a is equal to, this is sine bx plus c, we want the formula, and therefore we shall consider a as r cos phi and b I shall consider as r sin phi. Now we will come to know why we have selected these values. Now if a is r cos phi and b is r sin phi, what is the value of r and what is the value of phi, that we shall write. So squaring and adding, what we shall get, therefore a square plus b square is equal to, we shall verify here itself, r square cos square phi plus r square sin square phi. R square is common and cos square phi plus sin square phi is 1. So this is simply r square, and therefore what is r from this? R will be under root of this, or root of a square plus b square. This is the value of r. And now you see, what is the tan of phi? Tan of phi, or we may consider b upon a. B upon a will be equal to, b is r sin phi divided by r cos phi, and r cancels, sin phi divided by cos phi is tan phi, and from this phi will be, so take inverse function, tan on this side will be tan inverse, so phi is tan inverse b upon a. So these are the values of r and phi. So we have taken a as r cos phi and b as r sin phi. Now see what will be y1. So from 1 we suppose this as equation 1. Now put these values in 1 and then we shall see what it will be. So further from 1 we have y1 is equal to c e to the power ax into bracket. What is a? A is r cos phi and here b is r sin phi. So I shall write r also common and in bracket here it is cos phi sin bx plus c. Sin of bx plus c plus b is r sin phi. R is taken outside and therefore here it remains sin phi plus sin phi into cos of bx plus c. So this is the expression after substituting the values of a and b and taking r common we have obtained. Now you observe this expression in the bracket. It is cos phi sin sin of bx plus c plus sin phi cos of bx plus c, and this is the trigonometric formula. So what is the trigonometric formula for sin of a plus b? And that we have sin a cos b plus cos a sin b. And it is of the same form, or we read this first: sin bx plus c cos phi plus cos bx plus c sin phi, and that means a is here bx plus c and b is phi. So therefore this is, which is y1 is equal to r e to the power ax sin of sum of these two, bx plus c and phi, a plus b. A is bx plus c and b is here phi. So that is sin of bx plus c, bx plus c plus phi. So this is what we have obtained the right side. So using this formula. Now this is the first derivative we have obtained. Now we again observe what is the original function and what is its how the derivative become here. The original function is y is equal to e to the power ax sin of bx plus c, and the first derivative is r e to the power ax sin of bx plus c plus phi. So what are the changes in this function in the first derivative? Once we differentiate it, the function becomes that this term is there, r, which is not here. That means the function, original function, gets multiplied by r, and one more change is there, the exponential function remained the same and sine function remained the same, bx plus c also remained the same, but the angle is increased by pi. That means one time differentiation. So results y multiplied by r and the angle increased by pi. So once differentiation, therefore once differentiation of y results a function which is multiplied by r. Results a function which is multiplied by r and the angle is increased by pi. In the original function. So once differentiation of y results a function which is multiplied by r and The angle increased by phi. Likewise, we should write what is y2. So similarly, y2 is equal to, now y2 can be written from y1 multiplied by r and increase the angle by phi. So y2 is r square e to the power ax sine of bx plus c plus phi, that is plus 2 pi. Y3 as, again, every time in differentiation does this change, gets multiplied by r, angle increase by phi. So y3 from y2 will be r to the power 3 r cube e to the power ax sine bx plus c, sine of bx plus c plus 2 pi plus pi, that is 3 pi. Now we came to know the pattern of the differentiation. Y1 is this one, Y2 is, and Y3 is like this, and so on. What will be Yn? That we shall guess. And therefore Yn is, means nth derivative, and this follows, and so on. Yn is equal to nth derivative of y. That will be r to the power, see, it is y3, it is r cube, and for yn that will be r to the power n, and e to the power ax remains the same. Sine function, sine of bx plus c plus, this is 3 times angle we have added in y3, and in yn that will be n times the angle to be added plus n phi. So this is our nth derivative of yn, but we should replace the value of r. What is r? Is under root of a square plus b square, and what is phi? Phi is tan inverse of by. We have done this substitution to have a simplified function and to get a similar pattern. I am using this trigonometric formula. So we obtain this single function as in terms of addition formula of sine. So therefore we have used this substitution, and now we should replace the value of r and phi. So this will be equal to, and this is nth derivative means this is dn by dx to the phi is e to the power ax sine bx, sine of bx plus c. This is y, and its nth derivative is on the right side, and I shall write this here as r. R is root of this. We may write root, or we may write the power as 1/2, and it is raised to n. So therefore that may be written as a square plus b square raised to n by 2. Square root corresponds to the power half. E to the power ax sine of bx plus c, sine of bx plus c plus n times phi. What is phi? Phi is tan inverse of b by a, and thus this is our formula for nth derivative of e to the power ax into sine bx plus c. And now the formula can be used for whenever we have this type of expression. For example, if you want to find out say fourth derivative of e to the power 2x, I shall write here, for example. So what will be the fourth derivative of, with respect to x, of e to the power 3x into sine 2x plus 1, using this formula, you see. Compare it. What is n here? That is 4. And what is a is 3 here. And b is 2, c is 1. So it is a square plus b square. A is this value and b is this value. A square plus b square means 3 square plus 2 square. So I shall write in the same form, and raised to n by 2. N is 4 by 2 into e to the power ax remains same, e to the power 3x, into sine of bx plus c I shall write here, into sine of bx plus c means 2x plus 1, and plus n times means 4 times, 4 times tan inverse of b upon a. What is b is 2 and a is 3. Tan inverse of 2 by 3. So this is the derivative of such function. So this formula is useful to write the nth derivative of this product. And this may be simplified, it's 9 plus 4 etc. But how the formula is used, that you should note. Thus we have obtained the nth derivative of this function, and now likewise or similar to this, we shall obtain the nth derivative of e to the power ax into cos bx plus c, cos of bx plus c with respect to x. The procedure is exactly the same, and so we shall consider this as y. This as y, and we will see how the functions will be changing after differentiation. Let y is equal to e to the power ax cos of bx plus c. Differentiate with respect to x. So what we will get is y1, and again use the product rule. A e to the power ax, we have written it in the earlier expression also. Second function as it is, cos of bx plus c. Now the first function as it is, derivative of second, and the derivative of cosine is negative, so I shall write negative sign. Derivative of cosine is minus sine, and thus that minus sign I shall write first. This function is as it is, and derivative of cos of bx plus c is minus sine of bx plus c multiplied by b. So therefore this will be e to the power ax b sine of bx plus c. You note this is as it is, derivative of cos of bx plus c is minus b sine bx plus c. And here also we take e to the power ax common, and in bracket a cos bx plus c minus b sine of bx plus c will remain, and we use the same substitution, that is put or take a is equal to r cos phi and b is equal to r sin phi, and from this what is the value of r we have obtained? Under root of a square plus b square, and phi is the same substitution we are using, the same values will be there, and phi is equal to tan inverse of b upon a. And with this substitution, suppose this as 1, so what will be 1? Relation or equation 1 will be, that we shall now write. So therefore from 1 we have y1 is equal to, and we are putting r is a is r cos phi and b is r sin phi. So r is common in these two terms, and that I shall write common outside this expression. E to the power ax is there, and r is now cos phi, cos b of cos of bx plus c. So that will be in bracket cos phi cos of bx plus c, and next is minus b. So the value of b is r sin phi. R we have written outside, only sin phi will remain here. Sin phi sin of bx plus c. Observe it. And now what is this? This is a formula for cosine of a plus b. Cos of a plus b is cos a into cos b minus sin a into sin b, and therefore this is cos of a plus b, that is phi plus bx plus c or bx plus c plus phi, and thus this is y1 is equal to r e to the power ax, and that is cos of bx plus c plus phi. I have written this angle first and then this a plus b or b plus a, it is the same. So thus once differentiation changes y, once differentiation gives y multiplied by r and angle increased by y, the same thing. So we should write similarly what will be y2. Y2 will be this y1 will be get multiplied by r, means this becomes r into r square, and no change in this exponential function, but in angle of cosine it increased by phi. So that is bx plus c plus pi plus phi, that is plus 2 pi, and y3 is r cube e to the power, again it gets multiplied by r, and this angle increased by pi, cos of bx plus c plus 3 pi, and so on. And so on. What will be yn? Yn will be r to the power n. See, y3 is r cube, yn will be r to the power n, and e to the power ax cos of bx plus c plus, this is 3 times pi, and for yn it is n times pi. So this is our yn that we have obtained. Now we should use the value of r and phi, and then that will be the expression here for the nth derivative of y, and thus our formula will be nth derivative of y means this. So thus nth derivative of this function is equal to, see the right side, r to the power n. R is root of this, and that means a square plus b square to the power. Root means 1/2 power, and again it is nth power raised, so it is n by 2, and e to the power ax cos of bx plus c plus n times phi. Phi is tan inverse of b upon a, and thus we have obtained the similar formula for this function, e to the power ax cos of bx plus c. Only the change is in place of sine here is cosine, and thus this is our next formula. So thus we have obtained the standard form for some standard functions, nth derivatives of these standard functions. Now we will consider some examples using these formulae. We will have one example, say problems on this. Let's find nth derivative. Find nth derivative of say x square divided by x minus 1 square into x plus 1 with respect to x. Now we shall suppose this function as y. Let y is equal to x square divided by x minus 1 whole square into x plus 1. Now to use the standard formulae, we have this algebraic function formula, that is the derivative of 1 by ax plus b. This formula we want to use, and what is that formula? Nth derivative of this is minus 1 to the power n factorial a to the power n divided by ax plus b to the power n plus 1. This is the formula we want to use here. But there is only single term at the denominator, linear term, first degree term. But here it is a quotient form, and denominator also is product. So what we get for this is the partial fractions. So we shall first get the partial fractions and then use that formula. Now we'll check whether the partial fractions can be obtained for this expression. For that purpose, first we must check the degree. Degree of numerator is 2, and what is the degree of the denominator? Whole denominator, highest power of x. That here it will be x square multiplied by x means x cube. The degree of denominator is 3 and degree of numerator is 2. So degree of numerator is less than the degree of denominator, then we can write the partial fractions. Now further, let y is equal to write the partial fraction, again we can consider this as x square divided by x minus 1 whole square into x plus 1. Now this factor is repeated. So corresponding to that, the fractions will be a divided by x minus 1 plus b divided by x minus 1 square. If it is repeated 2 times, 2 fractions should be written in this way. If it is repeated 3 times, then one more will be there, plus c divided by x minus 1 cube. And so these are the fractions corresponding to this factor. And plus, now this is not repeated and linear, and that is c divided by x plus 1. We suppose this as equation 1. Now what we have to find out is the value of a, b and c. For that purpose, we write the equation. The numerator of this, take the LCM of this as x square, x minus 1 whole square into x plus 1, and then equate this. So numerator on the left side is x square. After taking the LCM as this, we have to write the numerator on the right side. And if take the LCM as this, here it is only x minus 1. So that means a is to be multiplied by x minus 1 into x plus 1. So a into x minus 1 x plus 1 plus b here is to be multiplied by x plus 1. So this is the arithmetic part, you should verify this. And next c is to be multiplied by square of x minus 1. C multiplied by x minus 1 square. And we suppose this as second equation. Now to get the value of the constant, you see, we shall put the value of x as, equate this to 0. X is equal to 1. So first put x is equal to 1 in 2. And what we shall get? The left side is 1 square, that is 1. And on the right side, this is x is 1, this is 0. And this is also 0, only the value of b will be, the second term will be non-zero. That is b into 1 plus 1, that is 2. And this gives b is equal to 1 by 2. Next we put x is equal to, say the second term, that is minus 1. Put x is equal to minus 1 into. And what we shall get? This is minus 1 square is again 1, and on the right side x is minus 1, so this is 0, but this is non-zero, and that is c into minus 1 minus 1. X is minus 1, so minus 2 square, that is 4, and therefore c is equal to 1 by 4. Now one more constant is remaining, that is a. And to get the value of a, we can put the value of a as any value. So I shall write now here. Put x is equal to, we may put 0. Any value we can use. Put x is equal to 0. So into, we get left side is 0, and on what is the right side? Right side is a, this is minus 1 into plus 1, that is negative a, and x is 0, so b plus b, and here also x is 0 means minus 1 whole square is again 1 plus c. You should check this. And now we use the value of b and c in this, so that is 0 is equal to negative a plus b. What is b is half, and what is c is 1 by 4. And thus a is equal to half plus 1 by 4. Take the LCM as 4 and multiply this by 2. 2 plus 1 is 3. A is 3 by 4. And thus you should verify how the values are obtained for A and B. Taking the denominators equal to 0, but we have 3 constants and one extra condition we have considered to be any value of x can be put in second equation to get the result. And we put these values of a, b, c in 1 and we get y as. So this is y. Putting the values of a, b, c in 1, we get. See, this is y. Y is equal to a is we have there last 3 by 4. 3 by 4 divided by x minus 1, and plus b is 1 by 2 divided by x minus 1 whole square. And next is c, and that value is 1 by 4 again. 1 by 4 divided by, the denominator is x plus 1. So thus we have obtained this this expression for y. Now we want to get the nth derivative of this. Differentiate this expression n times on both sides. So, but the second you should see, this we have to write in other way, and that differentiating, or this y can be written as 3 by 4 into 1 over x minus 1 plus, I shall write this term 1 by 4 into 1 upon x plus 1, and then I shall write 1 by 2 into x minus 1 to the power negative, I shall consider minus 2. And now we differentiate this n times using the formula. So differentiating this, n times, or taking nth derivative on both sides, we get nth derivative of y, I shall write yn. This is 3 by 4, nth derivative of this function. Nth derivative of this function, we use this formula. Minus 1 to the power n, that is into n factorial, same, and a here is 1. So ax plus b, a is 1 and therefore 1 to the power n, divided by x minus 1 to the power same. So the power is n plus 1, and plus this is 1 by 4. Similarly, it is minus 1 to the power n into n factorial into a is 1, again 1 to the power n divided by x plus 1 to the power n plus 1. But what about this function? And the nth derivative of that function, we have to use the first formula. That is, what is the nth derivative of ax plus b to the power m? We have this as m factorial divided by m minus n factorial into a to the power n into ax plus b to the power m minus n. So this is the formula, and using this formula for the last, so what is the value of m is minus 2, and that we can't use that because the power is negative 2, and negative numbers factorial is not defined, so we can't use it for the last term, and so that term should be obtained separately. So plus we should write here plus half nth derivative of x minus 1 raised to minus 2, and I shall suppose this as third relation. Because we can't use the formula directly, this is m, and here it is negative. Negative factorial is not defined. So therefore we have to obtain it separately. And for that purpose, we shall suppose, say z1 is equal to this function as z. Let, because y is used and x is also used, so we suppose this as z. Z is equal to x minus 1 to the power minus 2, z function, and differentiate with respect to x. What we will get is z1, first derivative of z, and on the right side it is minus 2 x minus 1 raised to minus 2 minus 1, that is minus 3. This is z1. So what will be z2? Z2 is again differentiate this, that is minus 2 minus 3 x minus 1 to the power negative 4 minus 4, and z3 will be minus 2 minus 3, it is minus 4, and x minus 1 to the power minus 5. Likewise, so what will be zn, and so on. Zn will be minus, it starts with minus 2, minus 2, minus 3, minus 4, and so on. Here it is 3, but here it is 4, and therefore here it is n, so that will be negative of n minus 1, and this is minus of n plus 1, negative of n plus 1. One more with negative sign, and into x minus 1 to the power. Here it is 3, here it is 1, here it is minus 3. So negative and number is increased by 2. Here it is 2, it is minus of 2 plus 2, and 3 minus of 3 plus 2. So n minus of n plus 2. So this much is the Zn, nth derivative. Or at the most, these are how many terms? You see, starts with 2, and there are n plus 1, last is n plus 1, and therefore we count this as 1, 2, 3, and last will be 1 less, that is n. So therefore negative sign will be common from each. These are n terms total. This is first, this is second, this is third, and this is 1 less, means n. So minus 1, minus 1, minus 1 means minus 1 to the power n. And this is, say, same as 1, 2, 3, 4, etc. And therefore that will be n plus 1 factorial. 1 multiplication by 1 doesn't change the value. So therefore it is 1, 2, 3, etc. up to n plus 1. And this term we can write at denominator, that is x minus 1 to the power n plus 2. So this is what is Zn. And Zn means nth derivative of this. And finally, putting in this in 3, we get so using this in 3, we get, now you see, this is yn is equal to, from this expression which is common, that we shall write minus 1 to the power n into n factorial is common from these two terms, and that yn will be minus 1 to the power n into n factorial is common, and last term that is n plus 1 factorial, that can be reduced, n plus 1 into n factorial, or one more step we can write as this is equal to minus 1 raised to n, this is n plus 1 into n factorial, reduction of factorial, n plus 1 into n factorial, and it is divided by x minus 1 to the power n plus 2. So this is what is Zn. Now we are using this Zn in 3, put in 3, and then now I can take this as common. It contains in each term, and what remains in bracket is here 3 by 4, or 3 is the numerator, 4 into x minus 1 to the power n plus 1, and here plus 1 divided by 4 into x plus 1 to the power n plus 1, and from the last this expression, here it is 1/2 plus 1/2, and these two terms are taken common, but n plus 1 remains at the numerator, so that we have to write n plus 1 divided by this 2 is there, 2 into x minus 1 to the power n plus 2. So this is our nth derivative of the given function. So you should note this we have obtained separately. There is no direct formula for this, and therefore we have obtained this. We have the direct formula for first two functions, and by observation the same procedure we have used as in the obtaining nth derivative of standard functions, and this is the required nth derivative of the given function. So in this way we can use the formula to obtain the nth derivative of function. So remaining part we will continue next time. Thank you.